Happy Sunday. This is PFG Live, the podcast dedicated to the writings of internet philosopher. Hey man, why didn't you? Hey man, why didn't you just use the wire from the MIG machine instead of the TIG electrode? Welcome aboard. We've got a select group of crazies forming in the Discord server. We got a bunch of folks coming in the door on YouTube. Welcome. Find a seat, grab some sandwiches in the back. We'll get underway. Mr. Warren Jones reports Sutton, New Hampshire at 80 degrees or so and cloudy. No wind and not horrible humid. It's enough humid, and it's coming. Before I go further, Evils couldn't be with us today, but he left his weather report, which is indecipherable. Josh is here from beautiful Winnipeg, in which he is reporting winds are 300 at 14 knots, visibility 15 miles, few clouds at 2,000, scattered at 25,000, temperature 19, dew point 07, altimeter 3007. Remarks. Can I read the Canadian remarks? I really cannot, but welcome aboard. Dale says it's 24 science and partly cloudy from the lake in the middle of nowhere, Alberta. Welcome, sir. Over on the YouTube side, Mr. Tim Beatty checked in. He said, it's hot. From Kilo Charlie, Hotel Delta, where the winds are 180 at 12 knots, 10-mile visibility. VCSH. Anybody know what that means? Anybody? Showers in the vicinity. Broken clouds, 12,000. Temperature 35. Dew point 14, altimeter 2992. Quentin checks in. Oh, no, actually, Russell checked in first. He says a toasty but decent 89 degrees, Frankenstein with winds out of the southwest and exceptional visibility in the Andover of Massachusetts. Andover. Quentin is checking in. He says at Echo Hotel Kilo Delta, automatic report 290 at 12 knots, 240 variable 330. No significant weather, scattered at 1600, broken at 2000, broken at 2700. A lot of brokens there. Temperature 14, dew point 10, and the altimeter is 1017 for you metric folks. And that's Den Helder Naval Airport, 30 miles north. Welcome. CJ is checking in, 81 degrees and overcast in East Tennessee. Welcome aboard, sir. Nice to see you. Hey, Microwave is here. Welcome aboard, sir. Nice to see you. Your signal is 5x9. Cal Tauber says it's 82 degrees, 50% relative humidity in the People's Republic of Rhode Island. Mr. RJ's Workshop says it's 41 degrees. Can we just dwell on this for a second? 41 degrees Fahrenheit. 100% relative humidity, quarter-mile visibility in fog in the mountains of southeast Wyoming. Welcome aboard. Very nice to have Wyoming checking in today. So, hi. We'll catch you as you check in. Don't worry. Don't be shy. First of all, thank you very much. We hit, like minutes before I sat in the seat, we hit 2,500 subscribers on this YouTube channel. Can you believe there are 2,500 people that actually want to hear this stuff, let alone see it? Thank you, and welcome. Nice to have you here. Looking forward to participating with you. I didn't catch Bill Olney. Bill Olney says it's 80 degrees Fahrenheit and threatening rain in Rome, New York, home of Air Force Research Labs. Correct. I think I caught everybody else. So we're gonna have a fun day. A lot of things to catch up on. Our main topic today is catching up on a project that started over a year ago. So when I say catch up, I am not kidding around. Test Room 2003 is checking in. He says, good afternoon from Oostkapelle, the Netherlands. 16 degrees science, 68% relative humidity. Nice to see you. Haven't seen you in a while. Did Warren? Yeah, Warren's typing. I'm looking forward to seeing what happens. Yeah, today we catch up on a project that's over a year old, and listen to one of my rants and answer some questions from some of our members on Discord. In particular, Dan S., who's not here, Dan Sav, asked a question which triggered a line of thought, which we're going to talk about. Yeah, Warren Jones says 2,500 subs, eh? More nerds than you thought. Yes, yes, it is. More nerds than I thought would admit it is what I'm trying to say. We have no community notes except for Evil's going off to a meeting, so he won't be here. I want to say we're going to have a new segment of our opening here called items. These are physical items that I was either handed, sent in, or asked about. And we'll get those out of the way before we get on to the more esoteric topics. One of those items, so I'm not going to identify the individual, but I was handed a box of these Radnor tungsten electrodes, pure tungsten. Now, for you welders out there, I know Warren knows exactly what we're talking about. Pure tungsten, 3/16 of an inch in diameter. This unassuming box of electrodes is rather heavy, and just to show you what it looks like, these things are formidable, very formidable. Now, I didn't look it up, but the torch. I don't know if anybody knows what torch size I would need to run a 3/16 inch TIG electrode, but it is not small. And I'm guessing, I mean, tell me if I'm wrong, is that if you're not running this thing at 200 to 300 amps, you're not running it at all. Am I right there, Warren? I'm not sure. Anyway, it is kind of otherworldly heavy. And I want to say thank you. And this came about because in the last podcast we were talking about tungsten, and we were talking about molybdenum as being a couple of specialty metals that my friends up in Maine make, up at Elmet. And he said, "Hey, I got some tungsten for you." And very, very few people people in specific trades can use these because they're so big. The normal ones we use are 7/32, I think, is the big one, and 1/8 of an inch is another size. But this guy is huge. So you TIG welders out there, you know what we're talking about. So thank you very much to that presently anonymous person for the goodies. We'll do something fun with them, I'm sure. In other news, we last time I talked about getting my goodies from Send Cut Send, and if anybody would like a Kinetic Precision coaster, which was part of that experiment, these were cut out of that material called AMS, I think it was called, which is the aluminum and plastic laminate that Send Cut Send has. It's usually used for signage. If anybody would like one, there's only 7 of them, and I will be happy to send you one. So just let me know. They're 4 inches by 4 inches, and they have the KP logo machined in, and I'll send you one. 3/32. Thank you, CJ Stevens, for correcting me. That's what I meant. I think my normal electrode is 3/32. Right. And 2/32 is 1/16, which is the one that I also have but rarely use, but it's good for small stuff. Thank you for catching me on that, CJ, keeping me honest. In other small stuff, I had mentioned a while ago that I was looking for a sensor that could hang on our Home Assistant network and measure current and voltage going to a load. And after some searching and recommending, we fell upon these little widgets. I'm holding one up to the camera from a company called Shelly, Shellly. So if you haven't looked at their offerings, they have a bunch of stuff which is intended to hang on an automation system. And lots of people are using them in Home Assistant. So this one, this cute little one, and this thing is, let's measure it. Look at that, get out the measure stick here in inches. It's 1.25 inches by 1 inch, and it's about 7/8 of an inch thick. So it's a really tiny little box. I didn't realize how tiny it was. I thought it was a little bigger, but I didn't check the numbers. And it will measure current and voltage to a load, and it operates from 110 to 240, and it will do up to 16 amps. So this is a pretty cool little device. So if you have a motor that you want to monitor, which is what I want to do, you can even hang this on just one of the legs of a 3-phase motor, and you will get useful information out of it and determine what's running, for example, or how hard it's running or how much current it's drawing. So little teeny weeny thing. This particular one is called the Shelly PM Mini. That's power monitor. Shelly PM Mini Generation 3. So that will be part of some future experimenting, and it will hang on our network. One funny thing I thought about this came up when I was doing the modifications to the band filter in the Okamoto grinder coolant system. So I wanted to put this in there to monitor something, and that may be the ultimate result. But what do you notice is missing from any indication or any like connection or anything on here? And the answer is, ironically, there is absolutely no indication that there's an antenna in here. That's because they never called me. Okay, they didn't call me. So you throw this thing into an electrical box and you seal it up. Guess what's going to happen? You're going to maybe get a signal out of it. So I'll report back when I first start playing with this thing. I might even open it up and have a look-see, in which case I will post pictures to the Discord server and show you. Also on the back, there's a reset button there. There you go. And of course, it's RoHS compliant, so you could feel good at night. So there you go. The Shelly Power Monitor is in the house, and we will be playing with it. Mr. Warren Jones advises the small stuff for welding tinfoil. He says, if memory serves, number 26 water-cooled torch or some automated machinery and used for big, thick pipe, aluminum maybe. Actually, it is. I believe it is aluminum, and other heavy stuff that need TIG welded. I would think 200 amps, 200 plus amps would be right. I have never welded with anything bigger than 1/8 of an inch tungsten and around 200 amps. So I didn't point that out, but he's absolutely right. So pure tungsten is an aluminum electrode. That is typical for old think aluminum welding. The new stuff, I like, all my stuff is 2% lanthanated now. But I'm sure there are still some processes that are calling for it. Russell says, I think also a number 12 Mongo-sized torch, if anything. I have never seen any tungsten larger than 1/8. Transformer machines use pure. So we could talk about that one day. Literally, we could talk about that one day. But I think pure was the original electrode. Pure tungsten was the original electrode used in heliarc welding when all this nonsense started. And the alloys with the special metals are just so much better now. But this is still cool, and I thank you. How do you... So Microwave says, just wrap 3 turns of number 14 on it and attach a connector. So you're talking about the Shelly, or I assume you're talking about the Shelly. So Carl asked, how do you connect this thing? So this thing is, it's got a line, a neutral, and then an output, LNO, right? So you hook your line, you have power coming into the box. You hook your line up, your neutral up. That's how this thing gets power to light up. And then the 2 terminals that are output, O, they are connected together. So then you can go off to your load from the output terminal. So that will now measure the current going from line to output, and it now has access to the voltage from neutral to output, and it has everything it needs, including power to run. Now that's the thing, is that when you lose power to this thing, it stops reporting in. And I'm not sure if I'm going to like that. We will get back to you on that. Does that answer your question, Carl? I think it does. And we'll report some more. Let's see. So in other items, in our new segment called Items, on the Discord server, Dan Sav, who I've known for a long time, Dan asks about getting grinding wheels for a particular machine. I don't remember the machine. I don't think it's super important, but he reported that it had a hub size non-standard, like it was 1.5 inches, I think. So I just wanted to show you some things, and we could talk a little bit about this. But this item is a diamond grinding wheel. This is a resin bonded diamond wheel. Okay. Oh, did I mention it has a B200 balancing ring on it to balance it to perfection? Available at PFGstones.com, or just go to pfg.gg/ring. Moving on. So this is a diamond resin bonded wheel. The way you read these wheels is over here. Oops, over here is the size 1A1. That's the size of the wheel. 7.5 inch diameter, or 1A1 is really the configuration of the wheel. It means a straight wheel. 7.5 inch. MCC is like I don't remember what the MC stands for, but it's a so-called coarse wheel. You have to look it up. X equals 1/8 of an inch. That's the thickness of the diamond resin coating around the perimeter. 100 CN is 100% concentration, which doesn't tell you anything, but trust me, that's fine. Maximum RPM 5175. So this is a McMaster Carr purchased wheel, 7.5 inch resin wheel. I don't know who makes it for them, but if we asked them, they would tell us. And then it's mounted on a hub. Okay, so this is this one happens to be a Sopco 0200 hub. And that's it. Now, what's interesting about this? Well, this is a piece of aluminum. So the core of this wheel is this aluminum? No, wait, I think this one might not be aluminum. Uh-oh, I might have said something incorrect. I think this one's steel. Yeah, this one's, I think, steel. So you have a steel core. The wheels that I use from Continental Diamond Tool, which is a very, very, very good vendor, hashtag not sponsored, they're also steel. So you have this metal core. Now, if you needed one of these wheels to go onto a hub, which is 1.5 inches instead of 1.25 inches, can you bore out the hole? And the answer is, of course you can. You're a machinist. So you can go onto your favorite machine and bore that hole out as long as you indicate the original hole, okay, and make the new hole concentric. So here is another wheel. Now, just for cost references, I believe this was about $120, this McMaster car wheel, which is kind of typical for this size and flavor of resin bonded diamond wheel. By the way, when I do PFG stones, when I grind PFG stones, I use a metal bonded diamond wheel, and they're just tougher. Okay, so but the price is tougher also. Those are in excess of $500, and for the same size. Just FYI. So a long time ago, when I was first learning how to grind stones, I bought some of these because they were available. I'll answer that. Good question, Carl. And these are smaller. These are resin bonded diamond wheels that are 6 inches in diameter, but they also have the 1.25 inch standard hole. And believe it or not, these were on, I think they were on Amazon. I think it was on Amazon for $30. So if you wanted to play around, that was quite the deal. And of course, you'll notice the markings on it are completely absent. There's no markings on it. So, you pays your money, you takes your chances, but that was another choice. So I would have zero compunctions about opening up that hole if I needed to make it fit on a larger hub. Okay. Yeah, Paul Morley says $30 and 30 thousandths out of round. So before we go too far, because there's two similar questions / comments here. Paul is implying that the cheap wheels are completely out of round, and Carl is asking how concentric does it have to be when you're putting a new hole in the middle compared to the periphery. So one of the tricks in dealing with these super abrasive wheels, that's the term of art, and I want to get back to that term, by the way, is if you bore that hole out a little big, meaning 5/6 thousandths of an inch big, you actually can now move the wheel around on the hub before tightening or while tightening to get the concentricity improved. So if you have a wheel where it is not concentric, I'm not talking about round yet, I'm just talking about concentric. If you have a wheel that's not concentric and you leave that hole a little large, you can tap the wheel into concentricity on the hub. Now, Robin Renzetti taught a method a while ago of taking the tightening ring, which is this ring, okay, the ring that binds the hub or tightens the hub to the wheel, and drilling 6 threaded holes on that ring so that you could use it with set screws. And there's a washer, it may be hard to see, there's a washer underneath that ring. There it is. And then the set screws will land on the washer. So you could lightly tighten up those screws, tap the wheel into concentricity, and then tighten up all the screws. Robin's method means that when you go to tighten up all the screws, you don't move the wheel. Whereas if you go to tighten the nut, once you get it concentric, there's a possibility that you could move the wheel because the nut is going around. Now, the washer, which has got a little key that drops into this keyway, is supposed to decouple that rotation from the wheel, but it could screw it up a little bit. So Robin's technique was pretty cool. And in fact, I use Robin's technique on the main diamond wheel on the grinder for making PFG stones. So that's one thing you can do, is you could bore out that hole to make it a little bigger so it gives you some room to get it as concentric as possible before you tighten up the hub. Now, once you put it on the machine, you know what you're going to do. You're going to true it anyway. You're going to dress it anyway. and you'll take out that last little bit. But if there's a lot of bit, you don't want to be dealing with that on a resin bonded wheel, or even worse, like way worse, on a metal bonded wheel. All right. But then there's the other question of how round is it? So if the wheel is really out of round, and I haven't checked this $30 wheel, but if the wheel is really out of round, you have to take care of that in truing, and you are in for a good time. That's facetious, in case you didn't figure that out. Because it's a slow process. And what do we use? We use molybdenum. So on the diamond wheels, you could use the molybdenum to remove diamonds, but you need control over your RPM. See pfg.gg/molly for that information. And there you go. So to answer I think I've answered your question, Dan, is if you can't get a wheel that has the right hole for that machine, for that machine's hub, then yes, you could take a wheel from that has a smaller hole and bore it out, or have a close personal friend of yours bore it out. Okay? I hope that works. So that's the other item. I think did I go through all the items here? I think all the items are taken care of. If anybody has any questions or comments about that stuff, just jump in. Oh, hey, Robin's here. Robin, I was just talking about you. Your ears must be burning. But that's all I wanted to cover on that. So the other thing that I mentioned, I think I wanted to mention the difference between Robin was the one who, said to me one day, if the metal bond wheels are going to last a lot longer, or stay in true and it dress a lot longer than the resin bond wheels, which makes sense. So that's why I went to the metal bond wheels, and they've been fantastic. And the company that I recommended to Dan as part of answering his question was Continental Diamond Tool, which is a company out in Colorado. I think they're Colorado, I believe. And they're just great people. They make a great product. They do custom work. They're fantastic. Hashtag not sponsored. Just like one of the good ones. Are they in Indiana? Okay. I don't know why I thought Continental. So they're in Indiana. So if you ever need a diamond wheel or CBN. So there's another so-called super abrasive called CBN, cubic boron nitride. I don't want to dive into that one, but that is used also sometimes, and that can be used for steel, and diamond cannot be used for steel because carbon. For another day. So that's a story on that. And I again, Dan, I hope we answered your question on that item. So the topic I brought up today was inspired this week. Troubleshooting is hard and failure is easy. It was actually inspired. It's not by a machining problem. It was inspired by a well pump problem. I get up one morning and I look at my phone and I have a text message from my son, who is nocturnal. Don't judge him. And he says, at about midnight, he says, we have no water. So now it's like, okay, we got to figure this out. So we start looking back on the history of what was going on with the water. Well, about a week prior, Honorable Wife reports we have a bunch of air in the water. So now I'm thinking, okay, what's our system look like and how can air get into our water? So I have a compressed air system, which is valved off, but it is valved off from our water system. It's used for blowing out our irrigation. That was one possibility. we called the guys at the well company, and they said, well, if you're they said if your check valve at the pump is leaking, then your water can drain out of the pipe, and then it could have air in it, and you can get air that way. That was another possibility. We were, I'm going back and forth trying to figure out what part of this relatively simple system, you would think, right? Relatively simple system is generating air into our water. And it was very, we came up with a couple of hypotheses, and we ranked them. We said, this is what I think it could be, and I thought the explanation about the check valve being worn out. I should point out that our pump is submerged. So our pump is down the hole about 300 feet. Okay. There's different types of well pumps, and this is important to the story. So that's why there's a check valve there, so that when it stops pumping, it closes the valve, so the standing water that goes up 300 feet stays in the pipe. So we had that hypothesis. Another hypothesis is that the valve that was between my compressed air system and our water system was leaking, and I was literally putting compressed air into our water. That was another hypothesis. I don't know if we had many more good hypotheses, but then I started to go downstairs, and I was troubleshooting now. So now I'm looking at, is that valve failing? And I reasoned that we would hear something if there was air leaking into the system. And I cracked it just a teeniest bit, and I heard the air go into the system. Then I closed it, and I listened carefully for air, which, by the way, is a method of detecting leaks in water systems, is to listen for high-frequency leaks, high-frequency sound representing leaks. Nothing. So this went on, and all of a sudden the water system cleared up. Everything was fine. Air went away. Water pressure was good. Everything was excellent. So we figured we can get on with life. And then came that morning that Jared says, we have no water. And we had already figured out what we were going to do if that happened. And at 7:30 in the morning, we called the company that services our well. And we said, come on over, and we need a new well pump. There's a story there. But it's a lot easier to deal with a complete failure than a marginal one. You know, those pesky, I don't know if Mike, if you're still listening, but electronics troubleshooting, right? Something's intermittent, something weird's going on. Hit it with the cold spray, hit it with the hot air gun, wiggle all the wires. You're looking for this little niggly little intermittent. And a friend of mine once said that where he worked, there was a guy who if you had an intermittent on a part, he would march in with a wire cutter and just cold solder joints. Dale's saying cold solder joints. He would march in with a wire cutter and just cut the thing out of the circuit board and say, there, it's not intermittent anymore. Which is only partially a joke, because now you could replace the thing and you could fix it. Well, the system did that to us. So in comes the guys, and the company, I'll give them a shout out, is Young Brothers here in our area. Family business. It's been a family business forever. And I pull out my records. In fact, it's right here. I pull out my paperwork from 12 years ago when they put a new pump in for us. And I noted one of the names on the list. So the guys come, and it's two guys, and the second guy is a young guy. First guy is an older guy, and I'm like, okay. Well, the older guy's name is Jim, and the younger guy's name is James Jr. And I said, okay, Are you that James Jr.? Because there was a James Jr. in my paperwork from 12 years ago. And he says, yeah, that was me. Turns out he was 14 years old when he was here. And he came back 12 years later to do it again. Long story short, 7:30 in the morning, we make the call. 8:30 in the morning, they show up. 10:30 in the morning, they leave, and the system's perfect. So, if you had your choice, now writing the check was not exactly a lot of fun, but it was like, it's done. It's probably done for at least the next 12 years. But, if something fails, just outright fails, it's a lot easier to troubleshoot than something that is intermittent, partial. Mike says, I just troubleshot an oscilloscope blowing fuses using a variac and my finger. Bring dial up slowly. Feel around. Stream indicates offending part. Scream indicates offending part. Yeah, touch all the parts until screaming. Replace that one. Good job, Mike. Thank you for sharing that. So if you don't know, a variac is a way to take the voltage, the mains voltage, and adjust it up and down. So that's what he's talking about. Mike has a great YouTube channel, Microwave One. You can see it on the screen there, and I've been on his channel also, helping him out. So that was the troubleshooting event of the week, and it reminded me how I would much rather troubleshoot a complete failure than troubleshoot an intermittent. And we have a new well pump, and it's wonderful. Okay. The main topic today has to do with the other side, has to do with designing. So it was about a year ago that Unix Carbide, also known as Ike, and I were talking about 3D printer design. So Ike has built, he built this magnificent Delta printer. I've seen it. And he's done some other cool things in the world of building your own 3D printer stuff. It's not his main gig, but he sure does have fun. And if you go to, if he has to make a 3D print right now, he's making it on his own Delta printer, which I think is fantastic. So one of the questions that Ike had was about resonances in these aluminum extrusions, which we love to build things out of. So, you've seen this thing hanging around because I'm in the middle of a project where I'm designing with it. This is 20 millimeter aluminum extrusion, and it has the nice grooves in it for all the nuts and bolts and sliders. Also, if you go watch Clow 42's channel, James Clow, he just finished building, I can say finished now. He just finished building the enclosure for his CNC project, and he's building it out of that type of material. But for the purposes of 3D printers, it was important that the structure be rigid and not have resonances. And we all know, well, maybe not all of us, but we all know what resonances do in a 3D print. In short, they show up. And if you ever look at a print, especially around a corner, and you see little vertical lines, that die out as it goes down the side of a box, that could be a resonance in the mechanical structure, because the head of the 3D printer just did a sharp turn, and it will have some evidence. Warren Jones says, what if it's a resin printer? Warren, I'm not saying you're a pain in the neck, except right about then. So, okay, it's a fair question. A resin printer doesn't have the dynamics. It's not moving around. And a FDM printer, as we call them, is. And the faster, the better. And as you know, I am now using bamboo printers, X1Cs mostly until recently. I only have one X1C left, and it's dedicated to a job. And then I've got the H2Ds. If you've ever watched an H2D fire up and start tuning itself, getting ready for the job, it is moving, okay? That head can move very rapidly. So there's two things you want. You want a mechanical structure that isn't going to ring. It's not going to have a resonance associated with it because that's out of control. And the second thing is they have a tuning system in the software where it characterizes what the system is doing, what kind of resonances are there, and then it adjusts the acceleration and deceleration of the head so as to stay away from those resonances. You don't want to excite those resonances. Dale says it still can happen on the Form 3. Really? Well, let's see. Is that... I don't know how that could happen, Dale, but I will we'll have to have a talk about that over a root beer. So, about a year ago, we instantiated this project to look at the resonance of the structures and the materials to see if that could be mitigated. So so Unix Carbide started building with this 40 millimeter extrusion, and we found a paper that talked about methods of dampening resonances in that material. And we went ahead and I shouldn't say we, but Ike went ahead and built some samples that employed the recommendations in that paper. And then I said, I'll get right to testing those. I won't tell you when that was, but we finally got around to testing those, and it was really interesting. So I'm going to show you some stuff, and I'm going to play you some short videos about that testing, and we'll talk a little bit about it. Mr. Tim Beattie advises that the Bamboo Labs annual sale starts tomorrow. Hashtag not sponsored. So if you're interested, go look it up. Mr. iPhone Doc, welcome aboard, sir, says, I'm in the middle of troubleshooting my Levin lathe controller. The forward reverse relay works, but the power relay doesn't. It is controlled by a Uniguard relay. Tough to find info about these. So I would recommend that you and Mike get together. Mike might be able to find some information about it. But if anybody has information on the Uniguard relays, put something in the chat so that Mr. iPhone Doc can get that information from you. Nice to have you here, sir. Paul says, our H2D sits on anti-vibration feet and is also on a desk that has a small bit of movement in it. The printer sways a fair bit, and I've wondered if the sway affects the resonance of the machine. Excellent question. So there's two ways to deal with machines, right? You can bolt them down to the center of the earth so that they can't possibly move, or you could put them on some isolators that have a little compliance so that they can move around. Dale has a couple of H2Ds. I have H2Ds, and I know exactly what you're talking about. The H2D... good. So Dale says, if you let it hit something, that screws it up. That sounds like he's making a joke, but he's not. There is a lot of motion in the H2D when it's firing up. And Mr. Tim Beattie says Bamboo goes through a resonance detection function. Yes, they do. It's very important to let it do its thing and let it sway on those feet and not hit something. Okay. The resonance, I'm going to put that in air quotes, of the machine, a mass, on those feet which are damped springs, is very low in frequency. So when you see the machine going wooga wooga wooga, that's a very low frequency oscillation. And if you were inside the machine, it would have very small input into the system, okay? And it would be at a very low frequency. The artifacts that come from 3D printing is happening at a much higher frequency. So instead of happening at a couple of hertz, it's happening at 100 to 1,000 hertz, let's say. So that's what that was the design choice in the design of the printer. Now, if you go back to the X1C printer, it also sat on some isolators, but they didn't have nearly the motion, okay, that the H2D has. So the first time you get an H2D printer and you see that thing going, it's like, holy crap, it's moving like 3/4 of an inch. Yes, it is. Let it move and don't put anything in the way. Yeah, so Josh says instructions are unclear. Got the printer damp with water. Now it doesn't start. Yeah, that's not what we're talking about, Josh. So let's quick review of the term resonance and the term damping. Okay. So let's do a thought experiment, and we're going to take a fishing weight, okay, and we're going to take a length of monofilament. Let's say it's about a foot long or 2 feet long. And if we take that fishing weight and we pull it out to the side and we let go, it's going to start swinging like a pendulum, okay? And you could measure the frequency of that pendulum, and you can say there's a resonance in this system, and that's the frequency of the resonance. Would you all agree? Okay. If we did this in a vacuum chamber with no air, and we did it with an absolutely ideal piece of infinitely thin material that was infinitely supple, didn't have any structure to it, that swinging would happen for a long time. Okay. Robin says, no. I don't know what you mean by no. Did I ask a question? So you now have a frequency, you have a resonance, okay? If I now introduce air into the system, the air has to get pushed out of the way by the fishing weight, which is swinging, and that represents damping. That is a loss of energy. And in your practical experience, you know that the swinging of the thing is going to eventually stop. Another way to look at that is, if you repeated the experiment underwater, I don't think you'd get any swinging out of it. It would start to swing and then it would stop. And that is overdamped. In other words, energy is coming out of that system very quickly by the interaction between the fishing weight and the water. Let's do another experiment. Let's take a ruler. Here's a ruler. And if you take this thing, hold it vertically. So I would argue that, a pendulum period is the same thing as resonance, because let's take it in physics terms, right? If you pull the pendulum up to the side and you let go, you now start trading potential energy for kinetic energy. When you first let go of that weight that you just pulled to the side, it has no kinetic energy, but it has potential energy. As it swings down to the 6 o'clock position, it's got no potential energy, but it's got kinetic energy. And now as it swings up the other side, it's going to have no kinetic energy because it's going to reach a velocity of 0, but it's going to have potential energy. And it's this sloshing back and forth between kinetic and potential energy that is, by definition, that's a resonance. And it happens at a frequency, okay? Let's take another example to make it a little clearer. In electronics, this is for Mike, in electronics, if you have a coil and a capacitor, and you put a bunch of energy into it, the current can flow out of the coil, okay, and go in, and it has a magnetic field, and that magnetic field is going to collapse and deliver current into the capacitor that's going to charge up. That's going to be an electric field. Okay, what's going to happen next? Well, that electric field is going to start delivering current back into the coil, and it's going to hit a very strong magnetic field. So you're sloshing energy back and forth from magnetic to electric and back and forth. And that happens at a frequency which is calculable, and that's a resonance. In a mechanical system, you have a spring constant, okay, and you have a mass, and those things lead to a mechanical resonance. So we introduced this thing called damping, right? Damping is how much energy gets lost in each one of those cycles. So if there's zero damping, it will oscillate in whichever form that oscillation is taking forever. Okay. If there is a loss, if there is a loss, then the system starts losing energy. In the case of a pendulum, it's going to start, its amplitude is going to drop. In the case of a vibrating tuning fork, its vibration is going to damp out and slow down until it stops vibrating. So in your car, for example, you have your wheel is on a spring. And if you've ever had a shock absorber fail, you know that can be very bouncy, okay? Because our shock absorber is a damper, okay? It is the thing which provides dampening. It literally turns motion into heat, and it removes that energy from the system. So in electronics, you have three things. You have the magnetic thing, which is a coil, the electric thing, which is a capacitor, and then the thing that provides damping, which is a resistor. In mechanics, you could have a mass and a spring, and then some sort of damping mechanism. So we've now established the definition of what damping is, what resonance is, and we want to get that stuff under control. In the case of 3D printers, we don't want to excite a resonance which causes a motion which we did not want. And of course, we already mentioned that bamboo printers will do a little dance and detect resonances and avoid them, or whatever they do. They modify their behavior. So let's see, I'm going to bring up the slides. Let's get a big picture here to start with. Yeah, there's a good one. So what we did here, and I'm going to switch to the big slides in a minute, and you'll see some more detail. But what we did here is we took a large chunk of the beam, okay, and we supported it on rubber bands. Actually, let's go to the big slide here. We supported it on rubber bands that crossed under it at the 22% points. So it's 22% from coming from one side, 22% coming in from the other side, and those are the nodal points. So when the beam is vibrating in the up and down fashion, okay, the nodal points are not moving, or nominally aren't moving. So by supporting it there, we're approximating it being in free space. And then we're gonna smack it with an impulse, and we're gonna cause it to vibrate, and we're gonna measure the vibration. The goal is to reduce the vibration to as close to zero as we can. So that's the goal. What we do to achieve the goal is to shove stuff into the middle of the extrusion to help with the damping. And in the case of this experiment, there's two materials we use. We use what's called rubber crumb, which is a bunch of rubber that's been ground up, in this case, into 1 to 3 millimeter particles. And we're using number 9 lead shot. So the recipe is you'll see 4 samples in the experiment. And the 4 samples are empty, which is the control group. That's what you're seeing on your screen. Full of rubber crumb, number 2. Number 3 is 25% lead shot and 75% rubber crumb. And the fourth sample is 50% rubber crumb and 50% lead shot. And then we take some data using a dynamic signal analyzer, which is a really super fancy way to say a spectrum analyzer. And this spectrum analyzer is pretty old. And just for fun, this spectrum analyzer has bubble memory in it. Go look that up on Wikipedia. So I'm going to play a video for you, and let's make sure that that you guys can hear this also. This is how we attach so there's an accelerometer that we put on the beam, and that's what we're showing here. Here are the bits and pieces for attaching the accelerometer. We've got the accelerometer, we've got a male-to-male adapter. That's the electrical connector there, and there's the attachment point, which is super glued on. So we're going to go remove that and put it on the next piece. Okay. So that was that's the setup. Where is it? Here's how we attach the little nut. It just uses super glue. And if you look at this little nut that comes with the accelerometers, it has grooves in it, and it makes a little plate, which is exactly like the the plates we make to hold parts using super glue. So it was a nice setup. Here's another shot of the setup for making the quick measurements. And now we're ready to take some data. Tim says resonance is a driven function. Robin is correct. Okay, we could talk about that later. And you could show me, talk about it in the after party roundtable. So here is a short video. Let's take a look. We're going to start fresh. So we've reset the instrument, and we're coming over here, and we're going to give this guy a little tap. And now we're coming over here, and there is our captured peak. We hit marker to peak, and it says we're at 2,440 hertz. And we're at a amplitude of minus 56.7 dBV. Okay, so this is our basic setup, and now we're going to modify the piece of extrusion and see what happens. Okay, so that's the setup. And now let's take a look at some of the results. So the first thing you notice is that the resonance from the unloaded, unpacked version of the extrusion is pretty sharp. Is a very sharp peak, and your ears immediately can tell that is. Okay, that's a good question, Robin. Your ears can tell that is a ring, right? There's a serious resonance there. Robin says with a smirk, why not attach the accelerometer at the nodal point? Okay, this is a really good point. I didn't explain it. Thank you, Robin. So let's do a little thing in the screen here. If this is our if this ruler here is our beam that we're exciting, the beam is going to be vibrating like this. Okay, it's going to be vibrating like this, and then like this. So as it's vibrating, this is what it's doing. Okay, there are 2 points where we can support the beam that are about where my fingers are here, that don't appear to move. Okay, and those are the nodal points. So we try to get our rubber bands right at those nodal points, right about there and there, so that the thing can basically behave as if it's in free space. Now I will point out there is another hidden resonance here, and the hidden resonance is the weight of the beam bouncing on the rubber bands. We'll get to that in a minute. So the points on the beam that are moving the most are the ends, okay, and the center. The ends and the center, okay? Those are the points that are moving the most. So that's why we put the accelerometer there. If we had a perfect system and we put the accelerometer on the nodal point, we would get little to no information from it. Now, the resonance, which happens from the mass of the beam bouncing up and down on the rubber bands, are not of interest to us in this particular measurement. So it exists, but it also exists at a very low frequency, and that's intentional. Okay, back to the pictures here. So let's see. So there's our peak from the very first control group. Here's a close-up detail of the attachment of the accelerometer and what the extrusion looks like, and this is obviously empty. I think that picture was just a picture. So here we switch to the rubber crumb, 100%. So there's a plastic 3D printed cover on the side that's holding the rubber crumb in, and when we hit this guy, notice that the sharp spike of resonance goes away, and now we have kind of a little evidence of a resonance. Now this is interesting because as we go through these measurements, this resonance and the resonance, let's see if I could point at it, this resonance and the resonance next to it, which are very, very soft, weak resonances, they kind of stay there. So there's something else in the system that may have the resonance. But this is with the 100% rubber crumb. That's what it looks like with the plug in the end. Okay, and that's what it looked like for everything that was filled. Next, we go on to the 2575. This is 25% lead shot, 75% by volume rubber crumb, mixed up thoroughly. Now look at what happens is that the resonance on the left is now very broad, and it actually is lower than this resonance that's creeping in on the right, which, you know, we're not sure what that is. And finally, the 50-50, which was pretty flat. I mean, there's some bumps here, but nothing is showing up as a strong resonance. And here's a little video which no, this is not showing up. Okay, we can't run that video. I don't know why we can't run that video. Well, we'll just write it up. I posted a video to Instagram. If you haven't heard it, or Discord, you could hear me hitting all of these things just using your earbones. It could be that there is a acoustic resonance going on, and that might be the higher one. I'm not 100% sure. Here's a very important point in this little exercise, is that the overall weight of this thing starts going up. So not only are we, getting this damping, but we're also changing the mass. So it is not lost on me that the mass of this whole beam is changing also. Now, one of the things that does is it pushes any potential resonance down in frequency, and it makes this thing too short to show up that resonance, which is okay. So if we wanted to get some more data at lower frequencies, we would have to use a longer extrusion than this. This extrusion was about 18 inches long, more or less, and it was pretty interesting. So that was the quick and dirty. Let's measure to see if this stuff works, and it worked. I mean, the resonances went away pretty quickly once we put in, I should say the resonance that we were looking at went away pretty quickly once we put the rubber crumb in. Once we added the, I shouldn't say went away, it was thoroughly attenuated. And then once we put the added mass in with the 25% lead shot, it got even better. So somebody asked me, hey, what about epoxy granite filled material? Because that's a thing, and that is that's a very stiff, nicely damped material. How does that work? So for all practical purposes, at the microscopic level, when that material bends, the interaction between the granite and the epoxy is essentially doing the same thing. It has to dissipate. It has to dissipate energy. And it's just doing it in something which is a solid, whereas the pouring in a mixture of the rubber crumb and the lead shot is not a solid. It's sort of a semi-solid. Another person pointed out that, gee, over time, wouldn't you expect that the lead shot would separate from the rubber crumb and move? And that's also a possibility. So all of these things are possible, but the main point was you're able to kill some of these resonances by filling the extrusion with something. And now I'll tell you about where to get the rubber crumb. The rubber crumb is sold as, I think it's a playground material that they put down on playgrounds that is, doesn't go away. It's not dissolving. It's not rotting, and it's kind of bouncy, right? No, I take it back. That was the bigger stuff. We looked at a couple of materials. This is the stuff they put in punching bags. Like if you have a punching bag in a gym, this size material is what they would fill the punching bags with. So it has a certain pliability to it. And the lead shot is lead shot. And if you don't want to deal with lead, then don't use it. But there's also a shot made with other materials. I don't remember what they're using these days for shotgun shells. That's not lead. There's something else. I don't remember what it is. So if you're building 3D printers, this is an area of interest, and one of the unsurprising results of this is that we received information that just this week that the new A2L printers from Bamboo Lab are incorporating advanced vibration damping through a combination of built-in hardware and smart software. And they report that they have built-in granular dampeners. Sealed chambers filled with fine particles are integrated directly into the top gantry rail. This aerospace-inspired hardware passively absorbs and dissipates frame vibrations through micro collisions before they can cause ringing or ghosting on your parts. Well, this is exactly what we're talking about. And they are, I think this is the first time I've seen it incorporated in a commercially available consumer grade printer, which is pretty neat. So Bamboo decided to do that this week. I don't know if that was, I don't know if that partially inspired me to bring this project in for a landing, at least at the point it's at. But it will be very interesting to see the results as people start building 3D printers using the technique, and of course, how the A2L, the Bamboo A2L, behaves with this feature. We will find out. So that was the news on damping the motion. Robin says, would hanging the beam vertically give cleaner results? Yes. One of the things it would do is it would get rid of that undesired mode, which is the beam bouncing on the rubber bands. So yes, in fact, you're on your way to wind chimes. You ever see wind chimes hanging, right? And if you ever look at how a wind chime is made, if it's made properly, is that it's a piece of monofilament that goes through a hole that's not at the end, it's not in the middle, and it should be at the 22% point. And then something hits the wind chime and it rings and sounds nice and it's wonderful. So that would be a cleaner result for sure, but a little harder to implement in the lab without doing crazy things. So I will get that paper. We had posted this paper in the Discord a while ago. I will try to get that into the video description for those of you on YouTube to follow that along. If you want to join us on Discord, you can head over to pfg.gg/Discord. I know, it's crazy. You got to fill out a form, be a real human, and then you will receive your invite. And that's it. If anybody has any comments, questions, quips, or promotions that you want to make in the chat, do it now, and we'll bring this thing in for a landing. We went a little over today because there was just stuff to cover. I don't think I have any notes. Let's see if I hit all my notes. Yeah, we did it. So if you want to join us over on the After Party Roundtable, where we usually have finger sandwiches and vociferous arguments, you could do that on the Discord server. We'll be in the After Party Roundtable. If you need something flat or something to help something get flat and stay flat, go over to pfgstones.com. And I thank you very much for your business. Get flat, stay flat, and we'll see you guys next week.